Hello and welcome back, static students. So here we have another Truss problem, and we're also going to be solving this one using the method of sections. So we're going to be looking for E of F, Fj, and Jc. So I'm going to go ahead and highlight those for you guys. So we're going to have our Cj, we're going to have our Jf, and our Ef. Now remember, like I said in my last video, you want to go ahead and cut that, and you want to pick your left or your right side. Well, just by looking at the Truss problem, I can see that they're both going to be basically the same. Because if you notice, this is sort of a symmetrical truss. So we're going to have basically the same amount of forces on each side of the truss. So I'm going to go ahead and pick the left side just because it seems smaller. I want to do it this way. So let's go ahead and solve actually A of y. So we're going to do the moment at B. Okay. We have our AY. Positive, that's our clue. You always want to stay which direction is clockwise or counterclockwise. I always like to do clockwise positive. So A of y times 18. Then we have 6 and the distance of 15. And if you notice, that's actually going to be counterclockwise. We're going to have counterclockwise 3 times the distance 12. Then we're going to have 3 times 6. And finally, we're going to have 6 times 3 is equal to 0. Let's go ahead and solve for A of y. Go ahead and plug that into your calculators. Okay, you should get 9 kilonewtons up. Good. Now, with that being said, we don't really need it right now, but we know that because it's symmetrical, we know that also B of y is equal to 9 kilonewtons. But again, this is not important right now. Okay, well, let's go ahead and start. As I did last time, we're going to go ahead and redraw our free body diagram. So it's going to look something like this. Okay. Yeah, no, my art skills are the best. I know that. Okay. Oh, and we don't have that. I know that's a pin. We should have an A of x, but we can assume that A of x is 0. Why? Because we don't have any other x forces on the entire truss. So we can just go ahead and assume that it's 0. Well, we know that it's 0. Okay. So we have our 6 kilonewtons here. Let me zoom in a little bit. We have our 3 kilonewtons here. And we have this force, and this force. Remember, every time you cut a truss, and whatever members are sticking out, basically, you always want to make those tension, always. Once we do the math, it'll tell us whether it's in tension or compression. Okay, so this is JC, this is our F of J, and finally our E of F. Okay, beautiful. So now we can go ahead and start. So let's see, we can try to do sum of forces in the X, but that won't work. We have too many unknowns. In the Y, we have too many unknowns. Okay, well, we have to take a moment somewhere, and we have to try to cancel as many forces as we can. So I think we are actually going to take a moment at J. Yeah, so J is right here. In this big picture, let me go ahead and erase these. This could be a little more easier to read. So we're going to take a moment here, and that's going to cancel our JC and our FJ. So we're just going to be left with E of F. So that's a very good spot. Okay, that's good. Okay, let's go ahead and solve that. So we're going to have a moment. Moment and J is equal to 0. Okay. So we're going to have our A of y times the distance of 6, correct? And that's going to be clockwise. Okay, and again, they always state, so I'm going to go ahead and just state it up here. Clockwise is positive. Okay. And then we have our It's going to be counterclockwise, 6. And that distance is going to be 3. And finally, we have our E of F. And that distance, we have to find that distance. I'm going to go ahead and call that H for now. Okay. So we have to find that distance. How do we find that distance? Well, let me see. Well, what we can do is let me just go ahead and draw it out here. We have a very big triangle, right? We know that it's 5.2. This is 9. So we're going to go ahead and find that angle. So we're going to use tan inverse 5.2 over 9, right? And our angle should be 30.018, okay? Now to find the height. So we do know that, you know, this is similar triangles and they share this angle. So let's look at this big picture. This angle's right here, right? And they share this triangle. Let me get the laser point. This triangle right here and this triangle right here. They're similar triangles, okay? And they both share this angle right here. Now there's two ways of trying to find this height. You can do, what's it called? I think it's called ratios. Yeah, ratios. So you could do ratios here, you know, because you know that this is 5.2. You know that this is 9 for the big triangle. You know that this is 6 for the small triangle. So you would just basically do a ratio. But I like trig, so we're going to do trig here. So we're going to go ahead and just do something simple. It's just going to be tangent of that angle is equal to x over, and we know it's 6. So x, well, I guess in this case, it's actually h. So h is actually 6 times tan of that angle. And h should be roughly 3.46. Let me just go ahead and plug that into my calculator to be sure myself. So it's going to be tan inverse. Oh, it's actually going to be tangent 30.018 times 6. Yep. So that's going to be our h. Okay, cool. All right, so let me just go ahead and put that up here. Our h is actually going to be 3.466. The angle's going to be 30 point. I'm ready to get because I'm actually going to erase this over here. Okay. So once you find your angle, your height, then the rest is just easy. Okay, so we're trying to look for E of F. So let's go ahead and rewrite that. We're going to do E of F is equal to 6 times 3 minus A of Y times 6 over H. Now go ahead and plug that in your calculator. Let's see what you get. Don't forget to distribute that negative. So EF, once you do that, you should get a positive answer, and it should be 10.38 kilonewtons. And because if it was positive, then that means it's in tension. Good. Okay, now we can move on to, I think we're going to have to do another sum of forces. Why? Because we still have JC and FJ. Now, if you notice these two forces, they're both going to have components. So that means we have the equal amount of unknowns. So we have to take another moment. Now we have to pick a moment again where we're going to cancel, one of these forces. So I'm actually thinking of taking a moment at F. Why? Because that's going to cancel E of F, and it's also going to cancel our F of J. So we're just going to be left with our JC. Okay. So let me go ahead and write that again. So we're going to do the moment at F. Okay, so our F is actually going to be right there. Okay. And here we go. So we're going to do our A of Y times 9, actually. And that's going to be counterclockwise, so we'll do that negative. Plus 6, because it's positive 6. It's clockwise, And then our 3 is clockwise as well. Okay, now the JC is going to be kind of tricky. Now, we found that angle, right? Because this JC, actually, it's this angle. So it's going to be delta. Okay, this is delta. Okay, so it's going to be in component form. So you're going to, there you go. Okay. Okay. So we're going to go and say CJ or JC cosine. Okay, now that it's an x force, so that distance is actually the same h, it's the height. Okay, and that's going to be giving us counterclockwise, so it's negative. And again, JC, that's going to be actually sine this time. It's going to be our y component, that's going to be just distance of 3. I don't know why I was going to put 9, but it's going to be 3 is equal to 0. That's also going to be counterclockwise. Cool. So we're going to go ahead and just move our JC to the other side, and we're just going to be left with a y9 plus 36 plus 9 is equal to JC. Those both turn positive, right? I'm going to go ahead and factor the JC out. It's going to be cosine h plus sine 3. I'm going to go ahead and divide that by this, okay? It's going to cancel. So we're left with cosine delta times h plus sine theta 3. Okay, and JC, go ahead and plug it in your calculator. Should give us 7.9955 kilonewtons, and it was negative, so it's in compression. Cool. So let's go ahead and just fix the way we drew our picture. There we go, and it's actually going to be pointing into. Okay. Cool, and we're just left with FJ. And now we can just do a simple sum of forces. Well, we'll do a sum of forces in the x, just because we have less x forces. So I'm E of F, that's positive, of course. And we have negative JC, and that's going to be using the cosine. And finally, we have positive FJ. We're going to see if that's correct. And cosine, that's going to be delta. Now, delta is going to be a little tricky to find as well. Okay. So let's go ahead and look at the big picture. So that's delta right there. Now, the way we could just solve this is using a little bit of trig as well. So I'm going to go ahead and just draw a little picture right here. Okay. We already know the height, it's h, and we know this is 3. So we can just do 10 h over 3, right? And finally data is 49.27. Okay, I'm going to go ahead and plug that up. I'm going to write this over here. 49.127. Okay. You should know by now that statics has a lot of trig, and by now you should be really proficient at it. Spot those triangles real quick. Okay. So, anyways, so that equals 0. So we're going to look for f of j. F of j is equal to JC cosine minus E of F. Divide that by cosine. Okay. You know what I just noticed? I've been saying delta for this for a while. This is actually delta. My bad. So this is actually alpha. Okay, now, yeah, I was looking at it and I was going to say, yeah, okay, my bad. So anyway, so divided by cosine of delta. There we go. That makes more sense. Okay, anyways, so plug that into your calculator. You should get 5.28-ish. And that was also negative, so we're going to go ahead and change that in our diagram. It's actually going to be pointing in. It's going to be in compression. So we have 2 compression and 1 tension. Now this problem was a little more challenging than the previous one. Still not too bad. And remember, we were able to find We were able to find the unknowns or unknown force in the members of the JC, FJ, and EF. We had to take two different moments to be able to find those forces. We did one of the moments was actually outside of the little truss or the cut up truss, but yeah, not too bad. So I hope this helps you guys and stay safe. See you next time.